our test over this. All right. And again, we're going to start with coterminal angles. Coterminal angles are how many degrees apart? 360. So if we add 360 onto 272, we get 632. If we subtract 360 from 272, we get negative what? Negative what? Negative 88. Okay. Easy peasy lemon squeezy. Are these coterminal? Are they 360 degrees apart? Ryan Morris says yes, they are 360 degrees apart, so it is yes. What quadrant is 154 on? Well, you've got your unit circle to use as a cheat sheet. 154 would be in quadrant number 2. Those are I's, not L's. Don't put L's. Don't type L's in there. Those are capital I's. Roman numerals use capital letters to name them. Okay? Yeah, I know you guys don't know much about Roman numerals or even how to read one of those things called a clock, an analog clock. Most people go, I don't know what time it is. I gotta look at my cell phone or my, what do you call this, an Apple Watch? Yeah, Apple Watch. I was gonna call it an iWatch. It was like, no, it's not an iWatch. It's an Apple Watch. All right. So yeah, people don't know how to read analog clocks anymore. All right, here we go. That was my little rant. How do we convert this to decimal? The 37, would we multiply it by 60 or divide by 60? Divide by 60. So you take 37 divided by 60. Give me that to 4 decimal places, somebody. 37 divided by 60. Point what? Thank you very much. And then you take the 59.6166 and divide it by 60, which is 0.99 what? 0.9936. So it's 83.9936 degrees. Okay? Divide by 60, add it to the net. So you take your seconds, divide by 60, add it to the minutes. Take the minutes, divided by 60, add it to the degrees. And there you go. Converting to degrees, minutes, seconds. Instead of dividing by 60, you multiply by 60. 0.1 times 60 is 0.6. So it's 28 degrees, 6 minutes, and 0 seconds because it worked out to be a whole number. Okay, if you would have gotten a decimal, then you would add a seconds part. Convert to radian measure, we multiply by pi over 180, and you get pi over 2. Now, you could look on your unit circle, find 90 degrees. Well, that's pi over 2 on your unit circle. So you could do it that way. 7 pi over 4 on your unit circle. 7 pi over 4 is what? What? 300 and 315? Oh, yeah, it would be. Boy, I'm space cadet today. All right. Coterminal angles when you have radians. You got to get a common denominator. What's common denominator with 5? 5, right? So you take pi over 5 plus 2 pi. Common denominator is 5, so you multiply by 5 over 5. So it's pi over 5 plus 10 pi over 5. What's pi over 5 plus 10 pi over 5? 11 pi over 5. So then you add another 10 pi over 5. You get 21 pi over 5. So those are 2 of the answers. So there you go. Draw the angle in standard position, 7 pi over 4. Well, whoops. Not that one. Not that one, because that's negative pi over 4. This is the answer, because you got to go around this way. 7 pi over 4 is that way around. Okay, arc length. Arc length on this So when you find arc length, is this in radians or degrees? Radians or degrees? Radians. So it's just pi over 2 times 8, which is 4 pi. Easy peasy lemon squeezy. Sector area, radians or degrees? Is this in radians or degrees? Radians. So it's pi over 3 times 24 squared, all divided by 2. Pi r squared over 2. Or the radians times radius squared over 2. So 24 squared is a big number. How big of a number? 576, right? So 576 divided by 3 is 192 pi over 2, which is 96 pi. Here, unit conversion ratios. Radians and radians cancel. Minutes and minutes cancel. I have revolutions per hour. 2 and 60 canceled to be 30 and 1. So 16 times 30, which is 480, divided by pi is what? What's 480 divided by pi? 152.7.8. Okay, I'll go with 0.8. 152.8 revolutions per hour. Okay. Be careful. Where people make mistakes is this. They take 16 times 30 and then divide it by 2 pi without putting 2 pi in parentheses. It's, if you take 16 times 60 and then divide it by 2, press equals, divide by pi, press equals, then you'll get the right answer. If you separate them into 2 separate things. But if you just divide by 2 pi without using parentheses, you'll get the wrong answer because you'll divide by 2 and then you'll multiply by pi unknowingly. That the calculator is doing order of operations. Okay, a windmill for generating electricity is 30 feet long. Depending on the wind, it rotates at various velocities. Find the angular velocity of it when it's going 70 revolutions per second. 70 revolutions per second. You will need it in radians per second. Well, I know there's 2 pi radians in 1 revolution. The revolutions cancel, so I get radians per second. I get 140 pi. Which I don't know what that is. What's 140 times pi? What do you get, Nikita? 439.8. All right. So the 30 feet long had nothing to do with the problem. Okay. You'll have a saw blade problem. You've seen a whole bunch of these over the course of this chapter. So 3350 revolutions per minute times 2 pi radians per revolution times how many inches is the radius? 7 inches in the radius times there are 12 inches in 1 foot and then 5,280 feet in 1 mile. So feet cancel the feet, inches cancel the inches, miles per minute, and then we want to change to hours, so 60 minutes over 1 hour. So you do all the math and you get an answer. I don't even need you to do the math. I think you guys can figure that out. Okay, planet Mars has a radius of 2,000 miles and rotates 1 revolution every 25 hours. Find the linear speed at a point on the equator in miles per hour. So it's 1 revolution per hour. I know there's 2 pi radians in 1 revolution. So I have radians per hour. I know the radius is 2,000 miles, so 2,000 miles in the 1 radius. Now I have miles per hour. So 2 pi times 2,000 divided by 25. Now we get into the second half of the chapter, where we're dealing with trig and the trig functions, the sine of A. When we're at 5, -5, what quadrant am I in? Where's 5, -5? 1, 2, 3, or 4? 5, -5 is not quadrant 2. 4. 5, -5 is right down there. So I'm in quadrant 4. Okay. 5, -5. 5 squared is 25. 5 squared is 25. 25 plus 25 is 50. The square root of 50 is my hypotenuse, which is the square root of 25 square root of 2, or 5 square root of 2. So if we want the sine, it's opposite over hypotenuse. Those cancel. Multiply top and bottom by square root of 2. It's negative square root of 2 over 2. Cosine is adjacent over hypotenuse. 5's cancel. Multiply top and bottom by square root of 2 over square root of 2. Get square root of 2 over 2. Tangent is opposite over adjacent. Opposite over adjacent, -1. Cosecant is hypotenuse over opposite. So 5 square root of 2 over -5. Those cancel, and it's negative square root of 2. Secant is hypotenuse over adjacent. Those cancel, it's just square root of 2. And cotangent is adjacent over opposite, which is -1. Here, I would use my unit circle. The sine of -3/4 3 pi over 4. Now, just so we don't make a mistake, let's use coterminal angles here. Let's add 2 pi to this. If we add 2 pi, -3 pi over 4 plus 8 pi over 4 is 5 pi over 4, right? So I want the sine of 5 pi over 4. I look on my unit circle. 5 pi over 4 is 225 degrees. The sine at 225 degrees is negative square root of 2 over 2. Cosine of 7 pi over 6. Hey, that's right on the unit circle. If you look at 7 pi over 6, if we look at the x, it's square root of 3 over 2. Tangent of 60 degrees. Tangent of 60 degrees is y over x at 60 degrees. Well, at 60 degrees, y is square root of 3 over 2. X is 1/2. So if we multiply both top and bottom by 2, I get the square root of 3 over 1, which is square root of 3. Cotangent of -4 pi over 3. Again, it's a negative. Let's add 2 pi onto it. So I have a nice coterminal, nice positive angle. So -4 pi over 3 plus 6 pi over 3 is 2 pi over 3. So I want the cotangent at 2 pi over 3. Well, cotangent is x over y, because tangent's y over x, so cotangent's x over y. At 2 pi over 3, I have x as 1/2, y as square root of 3 over 2, and x is negative, right? So, can't leave a square root on the bottom, but first of all, let's get rid of those 2's by multiplying by 2. So it's -1 over square root of 3. Then, how do I get rid of my square root of 3? Multiply top and bottom by square root of 3. So I get negative square root of 3 over 3, which is choice D. Inverse cosine of 0. What that is asking is, where is the cosine equal to 0 at? And the answer is 0 degrees. That one you could type into your calculator. It would give you it. Tangent, inverse tangent of 1. It's saying, where is the tangent 1 at? Well, again, you could type that into your calculator, and you could get 45 degrees. Where is the inverse sine of 1 at? At how many degrees is sine equal to 1? Well, that is 90 degrees. The tangent of an angle equals 4/9, which is that angle equals the inverse tangent of 4/9. What's the inverse tangent of 4/9? What? 24.0 or 23.9 something? 24.0 around soon. Yeah, sounds good. I'm good with that. The 6 trig functions for this. What's our first step? Before I can find any of the trig functions, what's my first step? Find the hypotenuse. 2 squared plus 9 squared. So 4 plus 81, 85. Take the square root. So it's the square root of 85. It wants it in radical form. Okay, so the sign. Opposite over hypotenuse, 2 over square root of 85. So multiply top and bottom by square root of 85. So it's 2 square root of 85 over 85. Cosine, 9 over square root of 85. And again, multiply top and bottom by square root of 85. So it's 9 square root of 85 over 85. Tangent is opposite over adjacent, 2/9. Secant is a reciprocal of cosine. Be careful. Don't go up to the sine. Go up to the cosine. So it's the square root of 85 over 9. Cosecant is the square root of 85 over 2. And cotangent is 9 over 2. When you're told to solve a right triangle, what you need to do is use the Pythagorean theorem to figure out A. So 3.64 squared equals 1.32 squared plus A squared. Now this is a calculator problem. I don't have a calculator up right now on my computer. So what's 3.64 squared? 13.2496 equals 1.32 squared. So if we subtract that from each side, I get 11.5 something. 5. I don't know what it is. And then take the square root. 3.39. Sounds good. Round to the nearest hundredth, 3.39. Then to figure out angle A. Angle A. You use what they give you. Don't use this one because it's a rounded answer. Use what they give you. Use B, which is 1.32, and C, 3.64. That's adjacent. That's hypotenuse. So you use cosine. So you go the inverse cosine of 1.32 over 3.64. If you use the inverse cosine, what do we get to the nearest hundredth as an angle? 68.7 what? 4. If that's 68.74, this is 21.26 because they have to add up to 90 degrees. Okay? We're almost done here. Find the exact value of sine, given cosine is 1/7 in quadrant 1. So you draw quadrant 1. Cosine is adjacent over hypotenuse is 1/7. We need the sine. So you just use Pythagorean theorem. 7 squared equals 1 squared plus x squared. 49 equals 1 plus x squared. 48 equals x squared. Take the square root. Square root of 16, square root of 3 is 4 square root of 3. So you get 4 square root of 3 over the hypotenuse of 7. The sine of 330, you look on your unit circle for the sine of 330, and you get -1/2. The sine of -8/3, well, you use coterminal angles. -8 pi over 3 plus 6 pi over 3, because you need a common denominator, is negative 2 pi over 3. So then you have to add another 6 pi over 3 to it, and you get 4 pi over 3. So the sine of 4 pi over 3, what's the sine of 4 pi over 3? Negative square root of 3 over 2, according to your unit circle, right? Okay, couple problems left. Sine of 5 pi over 6, again, unit circle. This is square root of 3 over 2. No, it isn't. This is 1/2. This is negative square root of 3 over 2. And tangent, use y, 1/2, over x, negative square root of 3 over 2. First thing you do is multiply both top and bottom by 2. So it's 1 over negative square root of 3. And multiply top and bottom by square root of 3. So it's square root of 3 over 3 with a negative. Cosecant, flip it upside down, it's 2. Cosecant, flip 2 over negative square root of 3 upside down. Then you have to multiply top and bottom by square root of 3. So it's 2 square root of 3 over 3. Cotangent, you flip over the tangent, or you take this and flip it over. So square root of 3 over 2, negative, over 1/2. Multiply top and bottom by 2. That cancels. This cancels. And you get negative square root of 3. Is the cosine of 2tan equal to the cosine of negative, or the negative cosine of 30? Well, the cosine of 30 is basically square root of 3 over 2. Cosine of 2tan is negative square root of 3 over 2, right? Yeah, it is. So this is a true statement. So 31 questions. It'll take you a decent amount of time to do this practice quiz. The more you do the practice quiz, the more you'll understand what's on the test. Test is the exact same questions, different numbers. That's all I have. You have an hour to work. That's why I went so fast today. To give you an hour to work on this. If you have questions, ask. Get to work.